good news and bad news to start off chapter 3. The good news is we're talking about equations of lines. Right? That's great news. I know you're all super excited. The bad news is we got to start off talking about standard form. Okay, this is probably the least used form that we're going to use. So we're just going to briefly get through this, not spend a lot of time on it because we want to spend time on slope-intercept form and point-slope form, which are much more useful when it comes to graphing. Okay, so bear with me this first section. Not too bad. We'll get through it, but yeah, standard form, we don't use it a ton, but here we go anyway. So in standard form, ax plus by equals c. And the x and the y, that stands for any ordered pair on my line, basically. So if I graph a line on a coordinate plane, something like that, the x and the y just stands for any point on that line. So it could be a point up there, for example. Okay, and the standard form always has the x term, and then the y term, and a constant on the other side of the equals. It's basically all it comes down to. And we got some rules to go with that. A has to be greater than or equal to 0. That's just a fancy way to look at it. A and B are not both 0. Because if they're both 0, then I don't have an equation of a line. I wouldn't have an x and a y. Okay, so 1 could be 0, right? A y could be missing, or an x could be missing. So for example, that's still an equation of a line. Same thing with this. Okay, those are still equations of lines, but if I didn't have any x or y, that's not an equation of a line. And a, b, and c are integers with a GCF of 1. So they got to be integers. They got to be positive or negative whole numbers. And if they happen to be something like this, if I had like 2x plus 4y equals 6, they got to have a GCF of 1. So basically what that means is all these are divisible by 2. So I could divide both sides by 2, which would leave me with x plus 2y equals 3 when I simplify. So now they have a GCF of 1 because there's an imaginary 1 in front of the x. So not going to spend a lot of time, like I said, just being able to get it into standard form or to tell if an equation is standard form or not. Well, first things first, let's determine whether each equation is a linear equation. Well, if I can get something into standard form, ax plus by equals c, that means it's a linear equation. I could graph it and it would make a line. And if that's the case, we're going to write it in standard form. Well, if I look at number 1, I have a term with x, that's good. I have a term with y, but what do I notice about that y? It's got an x with it. So do you think I can get this into standard form? No, I'm not going to be able to do that. So right away I can say, no, it's not a linear equation. So I cannot write this in standard form. So if I would have something, other no's that I might have is if I had a square on my x term, or I had a square on my y term, any exponent on my x or y, or the x and y being multiplied, those will all end up being no's. They are not linear equations. They'd make different types of graphs. Well, how about this one? I got an x term, I got a y term. That's good. Well, for standard form, I want to get the x and the y on the same side. Let's go ahead and do that. Well, I got my x on the left side. Let's bring my y over there by subtracting it. So get rid of my y on the right side. So 3/4 x minus y equals a positive 8. Well, then they have to be integers, right? With the GCF of 1. So how do I get 3/4 into an integer? Well, the easiest way is to get rid of the denominator. And how do I get rid of that denominator, that 4? All you got to do is multiply by that 4. Because think if I take that times 4, it's really 4 over 1. Don't the 4's cross cancel with each other? And I'm just 3 over 1, so 3x. Well, in order to do that, algebraically to make that work, let me put my 4 back here. If I want to multiply that by 4, I got to multiply the whole side by 4, which means I also have to multiply the other side by 4 to keep my equation balanced. Right? Whatever you do to one side, you do to the other. So now when I distribute this 4, 4 times 3/4 is just 3x, right? Because the 4's cross cancel each other. And 4 times a negative y is a negative 4y equals 8 times 4, which is 32. Well, the biggest number that goes into 3, 4, and 32 is 1. So they all have a GCF of 1. I can't simplify it. X and y are on the same side, and I have all integers now. So there we go. It's in standard form. So yes, this is a linear equation. I should have stated that right away. Yes, because I have an x term, a y term. They're not being multiplied together. I have no exponents on them. And I can get it into standard form. Get x and y on the same side. Make sure the coefficient on x, this 3, was positive. Make sure they're all integers, which I did, and that they have a GCF of 1. X-intercepts and Y-intercepts. You've probably heard of these terms before. X-intercept, right? If I intercept a pass in football, that's because the pass is supposed to go to the receiver, and I jump in front of it, and I intercept it on its way. So intercept is where it crosses. Like this line is basically intercepting through the x-axis, the x-intercept. So the x-intercept is where it crosses the x-axis. So right down here would be the x-intercept right there. The y-intercept, well, where it crosses the y-axis. So right here would be the y-intercept. And let me write the coordinates for both these. The x-intercept in this case is 3, 0. Those are parentheses, kind of fancy parentheses. And the y-intercept was at 0, 4. Well, I should notice something about the x and the y-intercepts. Every linear graph, every graph that I have of a line, the x-intercept is going to have a common thing. Right there. You see how the y is equal to 0? If I had another graph, let's say over here, my x-intercept is right there. Isn't my y value going to be 0? It does not move up or down. So every single x-intercept, the y is going to equal 0, isn't it? The y will always be 0 in the coordinate because the x-intercept, it's not leaving the x-axis. It doesn't move up or down. Well, the same thing kind of works with the y-intercept, right? The x will always be 0 for the y-intercept because it doesn't move left or right at all. So if I had a graph up here and I drew that point, the x would be 0 for that coordinate, right? It'd be 0, 9 in that case. The x is always 0 because it does not move left or right. And for zeros of a function, don't worry about that so much right now. The only thing we're going to think about it is that's the x-intercepts. The zeros of the functions are the x-intercepts. And we're going to cover that more in depth a little later. So I'm not even going to go into it right now. But the zeros of the functions would be your x-intercepts. So let's use the x and the y-intercepts here. I'm going to graph some equations just finding the x and y-intercepts. And I can do that. As long as I have 2 points on a line, I can graph my line. Usually we find more points just to be safe, to make sure we're right. But I can do that just by finding the x-intercepts and the y-intercepts. So if I want to find the x-intercept, the biggest key is we just said the x-intercept always has the y being 0, right? Because it does not move up or down. So that's all I want to do to find the x-intercept. I'm going to plug in 0 for y. So 4x minus 0 equals 4, which is really just 4x equals 4. Divide by 4 on both sides, and x equals 1. So there's my x-intercept. So basically, I just go to 1 on my x-axis, and I draw in my dot. And then I do the same thing for the y-intercept, except I plug in 0 for what? We plug in 0 for x now, right? Because it does not move left or right. So I plug in 0 for x. 4 times 0 minus y equals 4. Well, 4 times 0 is 0. So really, I have a negative y. Don't forget that sign that's in front of the y. You can't get rid of the signs that are in front. So that was 0, right? I don't need to write that. Well, essentially, I'm dividing by negative 1 on both sides. But what happens is I just switch the signs of everything. So if I divide by a negative 1, that becomes a positive y. Divide by a negative 1 becomes a negative 4. So I got a negative 4 on the y-axis. I draw a dot. Well, there you go. I got 2 lines, so I can basically draw in my line. And if I want to be a little more specific rather than just drawing the line through, I could keep using my slope. So from the red to the blue, I went up 1, 2, 3, 4, and right 1. So I can go up 1, 2, 3, 4, and right 1. Up 1, 2, 3, 4, and right 1. I can also go the opposite way, down 4 and left 1. That might be a little more exact when I draw in my line. Use your slope, which we're going to talk about. We'll talk about slope here in a couple sections. Very good. So just x-intercept, y is 0. Y-intercept, x is 0. Well, now it doesn't even tell me to say use the x-intercept or y-intercept. So no, that's one way you could graph a line, finding the x-intercept and y-intercept. So I'm going to do that. I'm going to find the x-intercept, which basically the y is going to be 0. So I plug in 0 for y. So I got a negative 2x. Don't forget that sign. divide by -2 on both sides, and x equals -1. So we go to -1 on the x-axis, draw our dot. Same thing for the y-intercept. But now x is going to be 0 because it does not move left or right. So we plug in 0 for x. Well, 2 times 0 is 0. Y minus 0 is just y. So that's gone, isn't it? So y equals 2. So I could just draw in my line, right, just like that. But sometimes I'm not quite exact. But really, from each dot, I'm going up 2, right 1, up 2, right 1. So I was pretty close there. Or down 2, left 1. That was pretty close there. So there's my line. So you could graph any line, if I haven't given an equation of line, by finding the x-intercept and the y-intercept. That's all we're getting at. All right, there's your assignment. Good luck to you.